Firstly, thank you so much for coming to this breakout session about AWS cost optimization. I am standing here today wearing two hats, and this entire presentation will present those two perspectives. The first one is as the CEO of a cloud cost optimization, AWS cost optimization tool called CloudFix, but the other one is as the CTO for a large group of about 150 enterprise software companies where we manage about 40,000 AWS accounts of our own. So I am going to present this, our learnings and our experiences, and share some of our insights from both of those perspectives. My name is Rahul Subramaniam, and I hope you find this conversation useful. We're going to leave some time at the end of this session for Q&A to ask specific questions because this is a fairly broad topic. Okay, so what we're going to cover today is three very simple topics. The first one is we're going to talk about some usage statistics that we've really uncovered and we find shocking. I assume you will find those shocking too, but it's good to share because once you understand what's really happening, it's easier to take remedial measures. The second one is we are going to talk a little bit about why different FinOps organizations, or even if you don't formally call the parts of your organization FinOps, why these groups that are specifically tasked with cost optimization, why they struggle with realizing all the savings, and why it takes so long. And then the last one is what we've learned about how to effectively realize these savings. So we're going to talk about these three topics today. Let's start with the first one, which is usage statistics. Okay, the first one I'm going to bring up is around EC2. Now, I'm assuming everyone around here has used EC2. By and large, having analyzed over $1 billion of spend on AWS, roughly 40% of all AWS bills goes towards EC2. And the shocking figure here is that the average utilization of instances, or EC2 instances, is just about 6%. How many of you guessed that that would be the case? Anyone? All right. It seems abysmally low that that's the kind of waste there is. And one of the biggest contributors to that waste are actually dev and staging environments. A lot of developers, they deploy dev and staging environments with the same capacity as they would production. And those environments barely get exercised or used. So there's a phenomenal amount of waste that goes in around EC2 instances. The next one is S3. Okay, everyone uses S3. S3 is one of the most used object data stores on the planet. There are trillions of objects that are currently stored in S3, and the staggering figure is that over 90% of them are accessed just once in their entire lifetime. That means the time that you actually put it into S3 is the last time that you ever access it. And for that exercise, you're then paying full standard access pricing. That means you are paying full price to make sure that that data is available for you in sub-millisecond latencies. And that just seems excessive for something that you're never, ever going to touch again, or that you haven't touched in years. So that's another staggering figure in terms of usage and waste. The third one is around networking. Now, networking is one of those really complex things that you have to set up in your environment before you get all your deployments going. There are VPCs, there are NAT gateways, there are all kinds of other features under the networking umbrella. But the interesting thing is that the default configuration, while easy to use and get started with, as you scale up your applications and as you scale up your deployments, one of the things that you will see is that those default configurations are at least 300% more expensive than when you fine-tune it and you refine it. To give you a simple example, whenever you're running the default configuration of your networking, and let's say you have an EC2 instance that is talking to S3. Did you know that all of that traffic actually by default goes over the internet? And you will get charged egress charges, and they are exorbitant. Okay? If you instead had a VPC route that routed all of that traffic via the local network or the internal Amazon network, it costs zero. So there are a lot of such best practices around how you should configure your network that will end up saving you tons of money. But by default, if you just don't do anything with those network configurations, they can actually cost you a lot more. So you have to really think about what your setup is. The next one is a very interesting way to look at costs. This is around RDS. RDS accounts for, it's one of the top 5 expenses that you will see on any AWS bill. And this particular use case is interesting in that people don't count the cost of, or don't account for the cost of managing your own database. Okay, it's not just the list price that you see on the AWS bill, but if you were to manage your own database and your own instance, it would pretty much cost you twice as much as if you used a serverless. And if you are following the recent announcement, there's a ton of new serverless database solutions like the Aurora Limitless, and Aurora Serverless has been around for a while. There are a bunch of options that are available. If you're not using those serverless options, you are in effect paying almost twice as much, because the cost of a developer who is sitting and working on patching up your instances, making sure that everything is up to date, that cost is unaccounted for usually on your AWS bill. And the staggering stat here is that 80% of the database instances are actually self-managed instances. They are not serverless, you're not using managed instances, and that is what is really shocking. So let's come to what you should do. And I'm going to share some of what we call fixes that you can take and apply them to your organization. I'm going to walk you through some of these. So let's start with the EC2, okay, all the EC2 flavors. Usually when you talk about EC2 optimization, the number one item in that conversation is right sizing, right? How many of you have heard the term right sizing? Everyone? Okay. So I want to take a step back and say it's a lot more nuanced than that. There are actually 3 flavors of EC2 optimization. The first one is what I call EC2 modernization, okay? The vast majority of EC2 instances are actually not on the latest generation of the instance family that they are a part of, okay? For example, if you're using general purpose compute and say you were using the M type of instances, you'll find that the vast majority of instances are still sitting on the M4 types, not the M7Is or the M7As, okay? So by sticking to the old generation and not modernizing the instances, you're actually wasting a ton of money. Let me bring up just the Amazon webpage on pricing. Is the screen visible to everybody here? Great. So I'm just taking an example of an M4 large, okay? M4 large is an instance type from about 3 years ago, okay? And even within our customer base, we find that about 60% of the instances are still on the M4 type, okay? Just within the M family. Now, this costs about 10 cents an hour. If you look at the EBS is on the old generation of hardware, so it is slow compared to what you get today. And the network is a very moderate network bandwidth that you would get. So for a lot of applications that actually require network bandwidth to do their job, where you might be transferring a lot of data, you might be doing a bunch of stuff, if you are on the M4 type, you would actually have to keep increasing the instance size so that you have the appropriate bandwidth to be able to do your processing and your operations, okay? Because on the M4.large, you only got moderate network bandwidth. Now let's see what happened with the M5, okay? So on the M5.large, we went from 10 cents an hour to 0.96 cents an hour, so that's about a 4% improvement. But look at the bandwidth. The bandwidth went up to 10 Gbps. So if you were having instances that were just moving files around and processing them, those kind of workloads suddenly got 10x faster. So you would probably need much less processing power and much less time on each job to do the same task. And by the way, those processors got 20% better between the M4 and the M5. So you got 4% cheaper, 20% better, just moving from an M4 to an M5, okay? We are still 2 generations behind. So let's see what happens when you move to the M6. And by the time we got to this, we got to the M6i, which is the Intel flavor. The price was the same, but you got another 20% boost in the performance. Okay? So we are already 50% compounded. We are about 50% better than the M4 by the time we came to the M6i. Sticking with the same architecture, we're going to stick with the Intels. If you went to the M7i, you're paying back to about 10 cents an hour, but here you went to 12.5 Gbps. Okay? You also went to about 14 Gbps in your EBS throughput. And you got another 20 to 30% performance improvement with the latest generation of chips. Okay? So the difference between an M4 and an M7i is staggering. In most cases, you can actually downsize or reduce the capacity or reduce the size of the instance by half, paying literally half the price by migrating to the next generation or to the latest generation. Now, this is very counterintuitive to what you would typically see in an on-premise setup, right? Every time you had to buy new hardware or upgrade to something new, it always costs more. But the paradigm in the cloud is completely different. When you're operating in AWS, migrating to the latest generation of instances actually costs significantly more. So as part of your optimization practice, stick with the same family, stick with the same thing, just modernize to the latest generation is going to give you a huge boost in performance, and overall your costs actually come down significantly. You need far less resources to do the same job that you were doing earlier. Okay? Okay, so this is, again, very, very easy to perform. Let's move to the next nuanced way of modernizing, or of making your EC2 instances more efficient. The next one is what I call retyping. Okay? Retyping is when you were on, say, an M7i, okay, or you were on an M6i, there are a lot of advantages to moving to Graviton. Okay, this is retyping. Here you're actually taking one instance family and you're retyping it to a completely different instance family. Okay? Now the Graviton instances, for example, are easily 40% or better, in terms of performance. Now that's a big jump. However, moving from Intel's or x86 architecture over to an ARM architecture may not be the simplest. You will need to do a bunch of testing. You'll need to do a bunch of performance verifications before you actually make the move. Okay? So they're not the easiest ones to execute. However, if you were running an Intel workload, and by default, by the way, when you launch an instance, they will always end up launching an Intel instance. Most teams don't have the knowledge to basically, or don't have the rigor to make sure that you are finding the best instance type even within the x86 architecture. So Intel is the default. You'll launch the Intel. However, if you move to AMD, and specifically the latest generation of EPYC Genoa chipsets that are there with the M7i instances or the C7i instances, those are absolutely phenomenal. The price performance boost that you get over there is in excess of 40%, just sticking within the x86 architecture. So in a lot of these cases, just staying within the x86 architecture, even not moving to Graviton, you can take a simpler path, but you can get massive performance boosts, and the net cost of running those workloads can be reduced, again, by a factor of 50%. Okay? So that's another thing that you should look at. This is an easy fix. For a lot of these scenarios, you can retype to another instance type that is significantly cheaper. The defaults are not always the most cost-efficient instance types. Okay? And last, we come to right sizing, which is what most of the discussion is around. And this one is where most developers will come back to you and say, no, right sizing is really hard. We can't do it. They'll give you a lot of, you will hear a lot of excuses around it, and they're valid. Right sizing is not the easiest thing to do out of the box. There are risks, for example, of shrinking your instance type too much, and in that sense, trading off some of the other parameters. Now, you have to remember that every instance and your workload's performance depends on 4 parameters at the very least. The first one is the CPU utilization, okay? The second one is memory utilization. The third one is disk I/O, and the fourth one is network I/O, okay? You have to take into account all four before you decide how to downsize. Now, the complication here is that while disk I/O, network I/O, and CPU utilization metrics can be gotten right out of the box, when you launch these, you can get them in CloudWatch. Really simple to get. When it comes to memory, because the memory resides within your VM, AWS cannot get you that data. You need to make sure that there is an agent that is installed inside those instances that is constantly monitoring your memory and publishing that data into CloudWatch. So it gets a lot more complicated. You need to have that agent. The further complication that comes there is if you're running Java applications or running a database, those applications are designed to use whatever memory you give it, okay? Even whether it's being utilized or not, the applications will basically end up using or taking up all the memory. They might use a subpart of it, which you will not be able to inspect. So memory utilization is one of the pain points of right-sizing accurately. That said, recently, AWS launched a new tool called the AWS Compute Optimizer, okay? The AWS Compute Optimizer is actually really smart in the way it looks at all of your metrics, and it is actually able to make recommendations that are extremely conservative and safe, okay? AWS does not want you to resize to an instance type or to an instance size that is going to put your applications at risk. So it's a really neat tool, and the amazing thing is that they just launched a really cool feature called customized recommendations in AWS Compute Optimizer. So I'm going to take a second to demo that to all of you. So if you go to the AWS Compute Optimizer page, it's a really simple thing in the console. You can go in there. The new feature that they just launched is the right-sizing preferences, okay? If you go to right-sizing preferences, now you typically, the argument that we saw over the last 3 to 6 months with the AWS Compute Optimizer was that teams would tell us that, hey, we want at least 40% headroom within these instances when we downsize. We don't want you to be, at 10% headroom, 20%, we want 40%. Or they would have specific requirements for how much headroom they wanted on those instances. And you could never do that in the past. However, this Sunday, AWS just announced a new recommendation feature, which allows you to customize that. So we'll just walk through that very quickly. So the first customization you can do is that you can restrict the scope of the recommendations to a particular region or keep it to all regions. So in this particular case, we just leave it for all regions. The next one that you do is you can also decide that your applications run best on instances of a particular class. So for example, if your applications are written in C, C++, or any of those languages, and you don't have the time or bandwidth today to move them over to Graviton, make sure that you can constrain the recommendations to instance types that fall within the x86 family. So you can choose the instance types over here. You get the entire list. You can select the specific instance types that you are comfortable running your applications with. Okay, things that you've tried, tested, they're the same architecture. It would be easy for you to take those recommendations and act on them. Okay, so if you want to disregard Gravitons because it's an architecture change, that's absolutely fine. Pick the ones that are easy. Okay, now once you pick that, you can go down, and the next thing that you do, and this is another big change. Again, defaults matter, so it requires a little bit of effort today, but it's totally worth it. By default, the Compute Optimizer used to have only 14 days of lookup. And then you could have enhanced metrics that would give you 90 days of lookup to decide what the recommendations are going to be. There's a new feature that just got added this Sunday, and that is to give you 32 days of lookup at no extra cost. Okay? Now, this is something that, unfortunately, you have to go into the console and turn on in every account, but I highly recommend that you do it. It costs nothing more. It's really simple, and you start getting really amazing recommendations because you have a broader window to basically look at all of your data. So change your setting from 14 days, the default, to 32 days. Just turn it on by default. And then you can set the P90 or P95 for the headroom threshold, and you can set the threshold to a value that you feel is appropriate for your applications and for your instance types. Okay? So if you haven't checked out the AWS Compute Optimizer, please do. It really simplifies the conversations around right sizing. Okay? There's this huge debate about why right sizing is so difficult that you will typically fight, with your engineers about. But use the AWS Compute Optimizer. It actually simplifies the conversations tremendously. You get recommendations that are safe, very relevant to exactly what you can act on. And the savings over here are phenomenal. Now, like I said, if you've done your modernization and retyping, in most scenarios, let's say you were using a 16XL instance, you could, at the very least, right size down to a 12XL in most of these cases. Okay? In a number of cases, you can even right size down to an 8XL. Okay? The cost savings over here are huge. Anywhere from 25 to 50% is easy. Okay? And if you remember the stat from earlier, given that your average utilization is only 6%, the headroom is huge. So please check out AWS Compute Optimizer and see if you can, have conversations with your engineering teams across these three different types of EC2 cost optimization strategies. Okay. Next, we are going to move on to storage. Okay. Idle resources are by far the biggest culprit when it comes to storage. Now, you've got instances. Sometimes you use spot instances. If you do that, awesome. But a lot of times, you actually have instances where you attached volumes to them. But when you kill the instances, volumes remain there as orphaned entities or orphaned resources. Okay? And that is by far the biggest culprit. What also happens within large development teams is that over a period of time, no one remembers who created those EBS volumes. No one remembers, or even S3 objects. No one remembers, why they were there, if they are important or not. And people are scared to delete those resources. Okay? So those sticking around in your account, EBS volumes, individually, they seem very, very cheap. But when you aggregate them over a period of time, they add up to pretty big dollars. Okay? EBS volume spend is typically in the top 5 spends on your AWS bill. And a large portion of that typically is idle resources. Okay? So pay attention and delete resources that you're not using. The next one is turning on intelligent tiering. And this one baffles me a little bit. So AWS created this thing called S3 intelligent tiering, right? It's a machine learning-based solution where AWS looks at every object that you have in the bucket. It looks at every bucket. And then if you've turned on S3 intelligent tiering, depending on how frequently you access the objects in that particular bucket, they will automatically switch those buckets to different access tiers, okay, or different access tiers. So the infrequent access tiers are actually significantly cheaper, and you can go all the way up to the glacier tier, which is almost like a cold storage archival tier, and that can be as much as 95% cheaper than what you're paying for as part of the standard tier prices, okay? The thing that baffles me here is that this is an absolute no-brainer. You should, by default, turn this on. Anytime you're setting up an S3 bucket, you should just turn it on and have AWS look at all of your access and move it to the appropriate tier depending on how frequently things are accessed. However, from all of our data, again, this is about $1 billion of spend on AWS that we've analyzed, the biggest savings potential that are left on the table is around this. Almost 30 to 40% of potential savings is never acted on, and that is all S3 intelligent tiering. And I don't know why they don't. So I've asked a lot of customers as to why you don't turn on S3 intelligent tiering, and I get excuses from, once a quarter we were going to scan through all of our objects, for an audit report. Now, if you're going to access that only once a quarter, it is better to pay the penalty for, to access that data from an infrequent access tier. It is way cheaper than to pay for 3 months, paying for full price, sub-millisecond or sub-second, sub-second access for all of that data. So there are infrequent access tiers where there's no latency penalty. So if your application actually needed to access that data, you're not going to have any latency penalties, but just that you are going to pay a little bit extra for that access, for that infrequent access that you're going to get. So it's way more cost effective. There's tons of money that's left on the table, but people don't act on it. The other one is EFS. Okay, EFS is a great tool. A lot of folks who come from the on-premise setup where they're bringing in their old workloads into the cloud, NFS is a very common thing that you use on-prem. To replicate that NFS-like environment in AWS, they end up using EFS. But then a lot of these EFS volumes, are rarely ever accessed, and the data just sits over there. There is an intelligent tiering with an infrequent access pricing that exists for EFS, and all you have to do is turn it on. But it's not done by default. Almost nobody turns on the infrequent access or the intelligent tiering for EFS. So these are two very simple things that you can do with any of your S3 buckets or EFS to start saving money. And the last one, which I'm really happy to report is actually very, very effective in terms of what people have adopted, is using GP3 volumes as defaults. Now, about 3 years ago, AWS announced a new volume type called GP3. The older volume type was called GP2, the old generation. Now, GP3 happens to be 20% cheaper than GP2. And in every scenario, it is as performant, if not more, than the GP2 volumes. So there's really absolutely no reason to keep your instances working with GP2. You should just have GP3 everywhere. And the beauty of it is, if you wanted to switch from GP2 to GP3, you can do that in the console without even an instance restart. Your applications don't go down. It's just handled automatically, magically, under the hood. You can go to the console. You can change the instance, the volume type from GP2 to GP3, and it is effective immediately. There is absolutely no downtime, absolutely no interruption to your applications or your service. It is probably one of the easiest cost efficiencies to get, and it's 20%. GP3 volumes are 20% cheaper. The good news here is that the vast majority of people who have heard of GP2 to GP3 make sure to implement it almost immediately, and we see very little waste anymore across our customer base where they are still stuck on GP2 instances. So that's very heartening to know. Okay, the last one over here is the blatant use of provisioned IOPS everywhere. In a number of cases, provisioned IOPS comes in by default. To give you an example, how many of you have used DynamoDB or used DynamoDB by default? Okay. By default, when you launch DynamoDB, you would have experienced this. It basically doesn't start with an on-demand provisioning of IOPS. It actually allocates reserved IOPS for DynamoDB. It's very true of a lot of other instances. For example, most developers think that if they are deploying a database, they need provisioned IOPS instance. So they will either go to one extreme where they will set up an IO1 or an IO2 volume type, which is insanely expensive because it has built-in provisioned IOPS, or they will take a general purpose IO and then provision a ton of IOPS in the hope or in the anticipation that there's going to be a ton of traffic on those databases. Instead, you should look at what the defaults are. The defaults will work for 90% of your scenarios, and I will guarantee that. The performance of these next generation volumes is actually pretty neat. And if and when you're starting to hit those IOPS limits, that is when you should think about provisioning IOPS. Do not provision IOPS by default. Use what is available. See whether you actually need them before you provision extra. It costs a lot to have pre-provisioned IOPS. So just something to watch out for as you're provisioning these resources. Okay, let's come to networking. Networking is actually really interesting. There is tons of idle resources that get left behind in networking. Not sure if a lot of you followed. Elastic IPs just got a lot more expensive. So elastic IPs are basically publicly addressable IPs. For a large number of services, the first set of IPs that you would get would be free. But about 2 months ago, AWS started charging for every IPv4 IP that was available as well. And then anytime you take an EC2 instance and decide that you want to make that instance available publicly, and a lot of developers, by the way, have this bad habit of, because they have VPCs, all of their systems are within VPCs, they will start up an instance, call it a jump box, they will allocate a public IP to it, they will log into that particular instance via the public internet because whatever, the VPCs and all, and the VPNs might be harder to navigate. But that's bad practice. It's also a security loophole to do that. There are better ways to access your instances. But jump boxes are the biggest culprits for elastic IPs being allocated today. And they will leave those instances. So even though they shut down the instances, the elastic IPs that you allocated will sit in your account. And they accrue. Every elastic IP costs you at a minimum $5 a month. And when you have tens of hundreds of these, you will not even realize that you actually have them, but they add up to a lot. The first time we discovered this a few years ago, we actually recouped about $35,000 in elastic IPs that were just sitting around doing nothing. Okay? So that it can add up to a huge amount of money. So take a look at those. Idle NAT gateways, again, NAT gateways are really expensive. Whether you use them or not, you're getting charged for them. So if you have VPCs and you're not using the VPC, but you attach a NAT gateway to it, delete it. Okay, there are easy ways to figure out which NAT gateways are idle. You can look at the amount of traffic that's flowing through it, and you should shut them off if you're not using them. Okay, VPC endpoints. Now this one is another interesting one. By default, a lot of the new services which have HTTP endpoints, things like DynamoDB, things like S3, a lot of these services that are offered over HTTP by AWS, the default traffic flow is over the internet. Okay, so you should set up VPC endpoints so that all of that traffic is routed via the internal network. Okay, every time data data actually moves over different availability zones or over the public internet, it actually costs you a lot. In fact, sometimes you actually get double taxed for data moving out of the network and then coming back into the AWS network. So you want to make sure that you have set up VPC endpoints wherever possible so that whatever traffic needs to flow within the AWS network is flowing within the AWS network. And it's really simple. It's as simple as adding one route to your routing table. It's really, really simple. And there's tons of documentation. AWS makes it really easy to do that even from the console. Of course, there are APIs to do that as well, but it's really simple to do it. A large number of AWS customers, especially those who are new to the setup, don't even understand this or know about this, and they end up with huge bills around their network traffic. So please spend some time and pay attention to these. The last one is S3 and CloudFront. Now, I've seen a lot of AWS customers set up servers for simple things like static web pages, okay? Or they will set up not just a Docker container or an instance, EC2 instance. They will then put an API gateway in front of that. They will then add CloudFront in front of that to make sure that there's low latency delivery of all those front ends. However, a lot of them don't realize that S3 is an amazing place to host your front ends. Whether you're writing your apps in Angular or React or any of these frameworks, you can export them as JavaScript content or a JavaScript app, put them into S3, and S3 is a good enough solution to actually run most of your websites. Now, if you want even lower latencies, put CloudFront in front of that, you will find that this is a far better and more resilient solution and costs a fraction to actually have as a regular basis as front ends. So any content that you have that can be treated almost like static content that needs to be delivered, use the pattern of S3 and CloudFront. to have the most efficient way of delivering that to your customer, don't start up servers, don't start up containers, don't start up API gateways to make that available to your customers. You don't need all of that. There are simpler, more cost-effective methods to delivering that to your customers, okay? Lastly, I'm going to talk about RDS, okay? Tons of idle resources, okay? People don't realize this, but if you are using RDS by default and not the serverless flavor, if you're using serverless, that's great. This is not a problem. But as long as you're using the other RDS flavors, the number of idle resources that you will see is the biggest chunk of cost. And your dev and staging environments are the biggest culprits over here. Every developer will end up launching a database. You're going to provision way more than you will ever require for that particular database. It'll run for a whole lot of time, and it'll just sit there wasting money. A simple strategy for this is delete all the databases, have one centralized serverless database. So let's say you were using MySQL or Postgres. I would recommend go with an Aurora serverless instance for MySQL or Postgres. Let developers use it like a multi-tenant environment. Okay, they will scale appropriately depending on what load is, what load they have to deal with. But all your developers can deploy their database as a new schema. Every schema can have dedicated users associated with it. And you can put an RDS proxy in front of it so that the database is being used as efficiently as it can. And again, just use that methodology instead of letting every developer do their own thing. In our environment, the first time we actually went through this exercise, we found about 4,500 databases across all of our accounts. And it was a nightmare to keep track of utilization because every one of those instances not only costs in terms of the cost, the price associated with that instance, but also the metrics to monitor them. The people who have to monitor 4,500 database instances, all of that adds up very, very quickly. Instead, as we move towards a centralized single Aurora serverless instance, we actually found that we could consolidate that into one single cluster that was really easy. It scaled really well. And we've had all of our developers tell us that the performance and the efficiency that they've seen with the centralized cluster is at least 10x what they got earlier. So some developers would typically launch something like a T4G Nano for their database, or they would launch something really small. And then when you launch these really tiny instances, trying to save money, you'll find that the bandwidth and the I/O on these are so terrible that your developers will, in effect, spend more time and money doing those queries and working with those machines. Instead, when you have one large consolidated instance, not everyone is accessing the database at the same time, but the net performance that each individual user gets on those instances is phenomenal. Okay, you'll have at least 10 to 20x performance boost, yet it'll cost you a fraction of what it costs you to have these independent databases. So try out that strategy. It works really well. I'm going to talk about resizing and retyping. This is exactly the same story as I was talking about with EC2. The good news is that if you are managing your own instances, the compute optimizer will also make recommendations for your databases. So the same story, the same strategy, go ahead and resize or retype your databases to exactly what you need and leverage the compute optimizer to do that for you. Okay, and the last strategy, I actually covered it under idle resources, but use Aurora, use the centralized database strategy, and use multi-tenant. Oh, there's two other things that I actually wanted to tell you. AWS Compute Optimizer actually has another really amazing feature. If you are a customer of SQL Server, right? A lot of people don't realize that the license fee on the SQL Server instance is usually multiples of what the instance cost is. Okay? Same with Oracle. Okay? When you have these two instances, number one, use Compute Optimizer. Compute Optimizer has a licensing optimization for SQL Server where it will tell you the right size to have for the most optimal cost, depending on what your utilization looks like, and try to make those two instances multi-tenant, because those licenses are based on the number of cores that you're using. And so you want to consolidate, you want to use as few of those as possible. And a lot of the customers that we've seen have saved in excess of 50% by just optimizing those specific kinds of instances, okay? Okay, the last of these strategies is what we call financial engineering, or being financially aware of how you can optimize your costs. Now, there are two strategies over here. AWS has a lot of different financial engineering discount plans that you can use. You, of course, have the compute savings plans that you should look up if you're unaware of them. The compute savings plans allow you to make commitments, 1 to 3 year commitments, and based on those commitments, you get a certain amount of discount. So you're basically trading off flexibility for discounts, and you can get as much as 70% discounts depending on what instance type and what kind of resources you're using. But compute savings plans are great for that. You also have other older instruments like reserved instances and convertible reserved instances that you can also use to kind of help manage discounting as long as you can make certain kinds of commitments. We at CloudFix have a solution that automates and manages all of that to maximize your discounts while minimizing your commitments, and it manages it automatically for you without you having to do anything. It's called CloudFix Retyping. You can come and talk to us about that a little later. But the thing that I want to point out over here is that you should figure out a way to leverage some of these discount plans and make the most of these other ways of saving money. Okay, now let's talk about actual implementation. And this is where a lot of organizations struggle. Now, everyone knows, we've had tools out there that have had these kind of recommendations for years, okay? I've been personally an AWS customer since 2007, so that's a little over 16 years that I've been dealing with all these different services. And at every point of time, there have been recommendation tools that have been available that tell you where you can go and save money. The hard part is actually saving the money. Okay? It's incredibly hard to realize those savings and put them in the bank. Okay? The typical reasons for failure that we've seen, not just within our own org, but also within our customers' org, number one is waiting for leadership to prioritize cost savings. Okay? How many of you here are from an engineering background or from a development background? Okay, so a sizable number. So you're all familiar with technical debt, right? Cost savings has the same issues as technical debt. Okay? You ask any developer on the planet, and they will tell you, we absolutely do not want technical debt in our code base. Okay? Yet, every code base has a phenomenal amount of technical debt, and the excuse there is, we just don't have enough time. Every product manager is torn between working on the technical debt and delivering features that the business wants. And in every scenario, the feature requirement and the delivery that's being requested by the business will always take priority over fixing technical debt. And that's why every code base has tons of technical debt. It's the same situation over here, where FinOps and optimization and making sure that you're working, because it's work, right? Making sure that you're working towards fixing a lot of these issues, that takes effort. And a lot of organizations find that the leadership does not prioritize it. But the same story applies when it comes to a trade-off between delivering features that the business needs and working on these optimizations. Delivering features will always trump on the priority list. Okay? So this is excuse number one, or reason number one. Reason number two is that a lot of these groups that are relatively newly formed, they'll say, we don't have a FinOps culture. Our developers don't take ownership of all the resources that they launch. They don't take ownership of the costs associated with them. And when you have a separate centralized team that's trying to drive these cost efficiencies, they're like, they don't even respond to us. We've sent them all these recommendations. We sent them an email about it. We sent them the reports. And it's gone into a spam box, or no one's ever even opened it. And that's very, very true in most organizations. And they blame it on the FinOps culture. But the thing about FinOps culture is it doesn't come overnight. Okay? It can take years to build, and you can't count on this as the only way to have efficiency built into your organization. Okay, third one. In a lot of organizations, these isolated FinOps teams, need basically buy-ins from multiple stakeholders. You need your finance team to be aligned and say, hey, this is a priority, we're going to drive this, we're going to cut costs. You need the business to be aligned to say, hey, we are going to do this cost optimization over here. You've got to be you've got to sign up for it, and getting your engineering team to actually execute on it. By the time any program or any recommendation kind of goes through all these stakeholders, there's at least one person objecting to it for reasons like timing, for reasons like priority, and things don't get done. That's the reality of the FinOps world. So let me give you a few tips about what I have found over the last 16 years to be effective. I've struggled with all of these over the years, and here are the things that have worked for me. Number one is the idea of chargeback. Okay? Now, FinOps is a relatively new field, but there's tons of content around FinOps best practices and principles. One of them happens to be chargeback. And sister principle of this is something called showback. Showback is basically when you get your AWS bill. The idea is that if you show your developers the bill, they will suddenly gain consciousness and they will feel like they own that expense and they will act on it. Unfortunately, it doesn't work. Okay? The priorities remain the same, nothing really changes. It's just something else that sits in their inbox, not acted on. Chargeback is slightly different. So it takes things one step further. It says, when you get an AWS bill, I'm going to take that and charge it back to the team so that they know what it costs. And if they know what it costs, they will act on it. Unfortunately, the way budgets work, developers have already budgeted for what it's going to cost to deliver a certain feature or certain product. So they don't really care about optimizing it. So when you charge them back, and if it is within the budget, they really don't care. So it's not really very effective. There is an interesting tweak on the chargeback that I have found to be extremely effective. And that tweak is to tax unwanted behavior and subsidize desired behavior. So this form of chargeback is, let's say I want every developer to turn on S3 intelligent tiering on the buckets that they use. Okay? And I find that most developers are not doing that. So every quarter, as a centralized team, I declare that anyone who does not turn on S3 intelligent tiering, okay, will be charged 3x the price that's on the AWS bill. And anyone who uses S3 intelligent tiering, hey, for this quarter, it's free for you. So we use the tax from the undesired behavior to subsidize the desired behavior. And the beauty of this is that you're never fighting your developers. Okay? You're telling the developer, you do whatever you want to do. I'm not going to fight you. You make the decisions for your product, but here are the rules. The rules are, if you are not following one of the best practices, the internal charge is 3x. The other advantage, the other side effect of this is that the minute you have this kind of charging, internal charging, your business teams get immediately aligned. Suddenly, the business owner comes in and says, why do I have this massive expense on my P&L? We didn't budget for this, right? This is turning out to be 3x more expensive than what we budgeted for. And you will immediately see alignment. The business will drive engineering to make the change so that instead of spending X, they're spending 0. Okay? So they will drive their engineering teams to reduce costs dramatically, very, very quickly. It requires a little bit of prioritization, but that prioritization will come in very, very quickly. Okay? So use chargeback as a tool if you are a central FinOps org. You can be creative with it. You don't have to stick with this forever. You can change the rules anytime you want. This is internal charging, right? So every quarter, create a catalog of what it's going to cost for a service to be delivered and use that as a way to change behavior. And remember, we talked about FinOps culture. You can actually change FinOps culture at 10x the pace within your organization if you use chargeback. The chargeback builds muscle memory. Okay? Every time someone got chargeback and they had to fix a problem, next time they launch an S3 bucket or they create an S3 bucket, they're going to think about, oh, I should turn this intelligent tiering on because otherwise I'm going to be charged 3x as much. Okay? So that's what culture is. Culture is nothing but the muscle memory of doing the right thing, and that comes from exercising it. Okay? Second one, enable your team with automations. Okay? Please remember that once you're in the cloud, things are operated at scale. Okay? This is not a one-off. You can't have a developer go into the console and go fix things. That does not work. The cost efficiency exercise is nonstop. Developers are launching resources, launching instances, launching all kinds of combinations of services. It's going to cost money. It's going to require you to stay on top of things to be efficient. So use tools. Now, there are three very important factors for the tools that you make available to your developers. Okay? And these are the principles that actually drive CloudFix. So CloudFix is a tool that actually does a bunch of this, but I want you to focus on the three key parameters for these tools that you give your developers. Number one is you should not ask your developers to make trade-offs. Trade-offs are hard. If you are asking your developers to choose between being cost efficient and delivering on performance, they're not going to be able to make that decision. Do not make your engineers or your developers make trade-offs when they're doing cost optimization. That does not work. Second, you want to make sure that they have to do very little, if at all, to get these savings. So if you add friction to what they're doing, they're not going to adopt it. Okay, you have to make it as low friction as possible. They should ideally not have to do anything at all. And the last one is you have to build trust. Any automation and any tool that your developers are using has to have trust, because if your automation breaks something, they will never, ever use it again. Okay? So your developers are the most finicky customers, if I can call it that, for any tool, any automation tool around cost optimization. So make sure that you pick a tool that has these three tenets that are built into it and can deliver that. So the developers feel like they can execute on these recommendations without really needing to make trade-offs and without having to do much work. That's how you make that effective. And lastly, you have to repeat this process over and over and over again. This is a non-stop exercise. You will have to stay on it for the very simple reason that AWS is constantly innovating. There are going to be new services, there are going to be new features, there are going to be new ways to do things. What was the best practices 3 months ago is not the best practice today. Just in the last 72 hours, there have been 150 odd announcements across all the different services. There are better ways to do things. Okay, so you have to stay on top of all of that. You have to do this repeatedly. Okay, to give you an example of, like, we think that we run a very tight ship when it comes to cloud costs and efficiencies. In our own setup, we claw back about $250,000 every week in waste. We have to run this nonstop. We are at it all the time, and every week we claw back about $250,000 in annualized savings just by staying on top of things. So it's a big deal. I want to do a quick shout out to CloudFix. This is a tool that we have that actually does a lot of this stuff. It can automate all of your, most of these recommendations, and we work closely with the AWS teams, and in particular with AMD as well. We have a partnership with them where all these right-sizing recommendations, retyping recommendations, and all the other AWS recommendations that you see in here, those are all, we work very closely with these teams to make sure that they are hardened. These have been running for years, and they make it really easy for developers to adopt them. It's really simple. You can onboard in a matter of 10 to 15 minutes. All you have to do is set up your account. Over there, it's secure, is the AWS recommended way of actually implementing a tool like this. It takes just about 15 minutes. It's very, very simple to execute. You can actually go try it out yourself at cloudfix.com/assessment. And by the way, the assessment is free. We actually want you to go log in, bring your accounts in there, scan your accounts, and see how much potential savings you actually have. Okay, it's really simple. You can then decide whether you want to act on it or not, or what strategy you want to adopt to act on it. But it's a free tool. Use it. Learn about how much savings there is to be had. And it's constantly evolving with all the best practices from AWS. So, use automation and tools like that. With that, I'm going to open it up for Q&A. I think we have about 5 more minutes. And I'm going to leave this on the screen. Please come and check us out at booth 1529. There's an amazing team over there who can walk you through things about CloudFix. And you can check us out on LinkedIn. The QR code is there. Apart from that, I also want to call out a podcast that I do called AWS Insiders, where we bring in AWS guests and customers to talk about best practices around how to leverage AWS to be efficient, to be successful in AWS, because it's a very, very large footprint. And also a live stream that we do every Tuesday and Friday at 9 a.m. Pacific time with my colleague Stephen Barr, who might be around here somewhere. There he is at the back. And so please check us out on the live stream. We talk about how it's a community. We love to share our experiences, and we take questions. We typically have guests from AWS at the live stream as well, trying to help answer questions that AWS customers have. So I'm going to leave that on the screen over here. And thank you once again. Please don't forget to rate this session on the app. That's it. I'm going to open it up for Q&A. If anyone has any questions around cost optimization, I'm happy to answer those. Thank you.